Hello students, in the last videos we have discussed many parts of motion. What is rest and motion, distance, displacement, speed, velocity, acceleration, dt graph, vt graph, and how we can derive the equation of motions. Today we will discuss the derivation of equation of motion with the help of a graph. Let us see how can we derive. We will take time in second along x-axis and velocity in meter per second along y-axis. Let a body start its motion with velocity u when the time 0. Here time 0, velocity u. After time t, the velocity becomes v. The body starts its motion with velocity u. After time t, its velocity changes to v. Now, from the point B, draw a perpendicular on x-axis. Let me take this O. And also draw a perpendicular from A on BC, which is D. At time t equal to 0, the velocity is equal to u. At time t, the velocity equal to v. We know, and I have explained that in VT graph, if we find the slope, then what we will get? We will get acceleration. Acceleration A is equal to slope of the graph. Slope is equal to y distance by x distance. Distance in y-axis by distance in x-axis. BD by AD. How can we find BD? Here OA is equal to U and BC equal to V. Here OA is equal to CD. CD is equal to OA is equal to U and BC equal to V. And BD is equal to, how can we find BD? BD you can find by subtracting BC from CD from BC. CD from BC. We have to subtract CD from BC, then we get BD. What is BC? BC equal to V, CD equal to U. And this is the time axis, OC equal to AD. AD equal to OC equal to time t. So we can put the value of BD. What we will get the value of BD? What we get the value of BD? V minus U. And AD equal to T. So A is equal to V minus U by T. That implies AT is equal to V minus U or V equal to U plus AT, which is the first equation of motion. This is all about how can we derive the first equation of motion from the graph. Now, We also know if we find area enclosure between the graph and time axis, then what we will get? We will get the distance covered by the body. The distance covered by the body, distance covered, S is equal to area of OABC. Area of OABC. Let us see this ADCO by OCDA is rectangle and ABD is triangle. To find the area of OABC, if we add the area of rectangle and the area of triangle, then we can find the area of OABC. Then we get the area of OABC. Area of OABC equal to area of OABC rectangle plus area of triangle ABD. To find the area of rectangle, what is the formula? Length into breadth. This is length and this is depth. OC into OA or OA into OC plus triangle area equal to half base into altitude. Half BD into AD. OA equal to, we know U. OA equal to U. OC equal to T plus half. BD equal to, we get here V minus U. BD equal to V minus U into AD equal to T. AD equal to T. Now U into T, UT, here S is equal to, distance S is equal to UT plus V minus U equal to, here we get AT from the first equation of motion, we get V minus U equal to AT, and you put here V minus U equal to AT into T. So S equal to UT plus half AT square, which is the second equation of motion. Now you see S equal to area of OABC. What is this figure? This parallel to this. If in a quadrilateral, one pair of opposite sides are parallel and other two sides non-parallel, then that is trapezium. The area of OABC trapezium. What is the formula to find the area of trapezium? Area of trapezium equal to half into height into sum of parallel sides. Half into, which is height? This is the height, AD. And these two are parallel sides, OA plus BC. OA plus BC. Area of trapezium in class 8th you read half into height into sum of parallel sides. Sum of parallel sides. Here AD equal to, we get T. AD equal to T. And OA is U and BC is V. This is V plus U. From the first equation of motion, we know at equal to v minus u or t equal to v minus u by a. At equal to v minus u and t equal to v minus u by a. If we put value of t in this equation, v minus u by a into v plus u, a plus b into a minus b, a square minus b square, v minus u into v plus u, v square minus u square by 2a. Therefore, v square minus u square equal to 2s. And this is the third equation of motion. This is all about how can we deduce but derive the equation of motions from the VT graph. Now we know all the theories of motion chapter. Now we will discuss some numericals in the next videos. Well, in this chapter, what we know now? First, we know the rest and motion. What is rest? What is motion? What is distance? What is displacement? What is a scalar quantity? What is a vector quantity? What is average speed? What is DT graph, VT graph, and how can we derive the equations of motions? Now we know how can we derive the equation of motions from the graph.